Okay, grade 8s. I just thought I would just randomly pick some questions that I thought might help you in terms of giving you some guidance on how to solve them. Okay, so I'm even going to stretch this out to lesson 6. So I'll do 1 or 2 from lesson 4, 5, and 6. Pay no attention to that. That was just me starting the word lesson with the spelling mistake. So anyways, so here's the triangle. And I guess my comment about lesson 4, 5, and 6 is this. They're not really that different. They're just chunked. So we've done a nice job in the booklet to break down different types of questions. But I want to say they essentially boil down to this. Okay, and I think I spoke to at least a few classes about this. When you have Pythagoras' theorem, okay, and that's the theorem, all right, inevitably all these questions boil down to in terms of, you know, what you might be asked to solve for. So what could I solve? Okay, well, there's basically 6 pieces of information. In terms of area, you might be asked to solve, like find out what the square of the A side is, or the B side B squared. Or you might be asked to find the area of side C, the longest side. Remember, this is the hypotenuse. All right, and then you might be asked to find the side length. All right, so you might be asked to solve for A, or B, or C. So basically, like, that is the whole unit right there. So we're going to give you different pieces of information, and we'll always give you enough information to solve for whatever we're asking to solve for. So let's just take a look at this triangle again. It's the famous one. It's the 3, 4, 5 triangle. Okay? So remember, one critical aspect or one critical part of Pythagoras is identifying side C. This is side C. It's also the hypotenuse. And it's always the longest side. Always. You must be able to identify side C. Okay? And then you know from there, you can do all sorts of neat things. You can find the square of this side, right, which is 16. And you can find the square of this side. I'm going to kind of do this fast. And the square, the area, is 9. The area here is 16. And then if you know, I'm not going to finish all of this square because it's huge. But you know the area here is 25. So you may be asked to solve for this number, this number, this number, which are side lengths, or you might be asked to solve for areas. Okay? So let's have a look at a few of these. Okay, this is page 29. Okay, question, I'll do question B. The following images are right triangles. Calculate the missing area. Calculate the missing area of the square and the side lengths and side lengths of the right triangle. Okay. So a couple of classes I did this one, a couple of classes I didn't do this one. Actually, I'm going to do A because I don't like this diagram. I did this with 8 3s, I think. And this diagram makes no sense. So let's look at this one. Okay, 25 centimeters squared, 9 centimeters squared. What was my trick? Always take the arrow, point it at the hypotenuse, and it literally says C squared, so you know that the side length is C. So calculate the missing area. Well, that's pretty straightforward. We're given, remember, it doesn't matter if it's one of the smaller sides. We don't care which one is B or A. So I'm just going to call this A and B. So the area is B squared. The area is A squared. What is A squared? It's 9. The area here is 9. I should use a highlighter. The area here is 9. The area here is 25. Okay? So 9 plus 25 will equal C squared. 9 plus 25 is 34. So now I have solved for the missing area. This area is equal to 34. All right? Now let's find the side length. So you could be, like, you could stop here in the sense of we calculated the missing area and now that's done. What is the side length? Well, to find the side length, you need to take the square root. Whatever you do to one side, you do to the other. These are the complete yin and yang to each other. They're opposites. So they knock each other out. They cancel each other. The square root of 34 is equal to C. Let's see what that is. 5.8. You can use the nearest tenth. Okay. Now it says find the side lengths. So remember, 25 is not the side length, and 9 is not the side length. So A is equal to the square root of 9. So that's equal to 3. That was pretty straightforward. It's a perfect square. B, oh, that also is a perfect square. That's going to work out nicely. 25, 4. So calculate the missing area, did it, and the side lengths of the right triangle. So I've done that now, right? I've got this. That's the side length, side length, side length. So this triangle, this A is 3. This B is 5. This C is 5 point, oh, sorry. Now, if you guys were in class, you would have made fun of me here, and deservedly so. Holy Dinah. The root of 25 is 5, and side C is 5.8. Good thing I caught myself there. Okay, that was page 29, number A. Okay, this is page 30. I'll do the teacher example. Given, okay, you always have to identify what's been given. Given 2 side lengths, all right? By the way, just a pro tip here. If they give you 2 side lengths, you can solve this entire thing in terms of like, I can find this missing side length, I can find this area, I can find this area, I can find this area. So everything is solvable just by giving 2 side lengths. So, happy moment. Find the areas of the squares. Okay, so that's going to be 1. And then find 2, the area of the shaded square. And what is the missing side length? So there's like 3 things to find. Okay, well, the first thing is we have to assume we're given. It's not asking us to prove it's a right triangle. Like, we have to assume it is a right triangle. Okay, because that's a different type of question. So this is a right triangle. You can see where the 2 sides come together at 90 degrees. That's the 90-degree angle. So this must be side C, and the area must be therefore C squared. This side length is 16. So we can also find out, now, again, it doesn't matter which one you call A or B, so I'm just going to call this A. So A, the side length is 16, so we should be able to find out A squared. Given 2 side lengths, so I'm claiming now that I'm going to call the 16 side A, and the B side therefore is going to be 11. The C is I don't know. A squared is I don't know. B squared is I don't know. And C squared is also I don't know. This is what I'm talking about, grade 8s. If you're just given 2 side lengths, all of these become, actually, like 3 of these answers are going to be very straightforward. Okay, let's see how this works. So, what's our Pythagorean theorem? It says A squared plus B squared is equal to C squared. Okay, so I said I was going to call the 16, this side here, the A, so 16 squared. B squared, 11. The side length is 11, so we're going to square it now to find the area. And that's equal to C squared, and we don't even have a side length. Okay, 16 squared, 256. So guess what? We just solved this. This is done now. A squared is equal to 256. Okay, plus B squared, which is 121. So guess what? We're done. B squared is 121. Is equal to C squared. Okay, let's add that up. Okay, that would be 7, 7, 3. Okay, so 377 is equal to C squared. Guess what? That's done. C squared is equal to 377. Okay? Sorry if my writing's sloppy. It always gets wonky near the spine. All right, now, so suddenly, like we're only missing one thing. Do you see how fast that happened? Like we started with 2 givens, right? We were given this, and we're given this, and suddenly now we're only missing the side C. Well, that's pretty straightforward. All you have to do is take the square root. Take the square root of both sides. The square root is the complete opposite. It's night to day. It's the up to down. It's the left to the right. They're opposites. They knock each other out. So the square root of 377 is equal to C, and that's equal to 19.4. You see that? 19.4. Okay, 19.4. And guess what? This is done now. 19.4. So look at, we've got everything solved. So we can solve for side lengths. Remember, those are first dimension. They're just literally the side lengths. And we could solve for the areas. So I guess it said shaded area, and that was 377. Okay, that was page 30, the teacher example. Okay, this is page 31. Look at the right triangles, identify the hypotenuse. Explain how you know. Well, one little trick here is go straight across opposite from your right angle. This is 90 degrees, this angle. And so this is the hypotenuse. Okay, it's also known as side C. Now, over here, look at your areas. This area is bigger than this area. Therefore, this side is bigger than this side. And of course, this little tiny thing, it can't compete for the hypotenuse. The hypotenuse is the longest side. So therefore, our little square is there. This number represents C squared, and the side length is C. And this is the hypotenuse. Side C is always the hypotenuse. These terms are interchangeable. Okay? I think I'm going to let you do that one. I think it's pretty straightforward. Okay, determine if the following triangles are right triangles. Well, remember, determine if, so we don't know yet. It's like I could draw this little symbol in, but I actually don't know if this is appropriate or true. So it's saying we're trying to fool you here. Some of these might be right triangles, some of them might not be. The proof is in the Pythagorean theorem. It must hold. The statement must end up being true if they're right triangles. Let's test it out on two of them, okay? So let's do this one. A squared plus b squared is supposed to equal c squared. Now, obviously, this one is side C. Okay, certainly the longest side is supposed to be side C. Let's see if the numbers work out. We'll call this side A, we'll call this side B. So the area, A squared is equal to 25, B squared is equal to 144, C squared is equal to 169. I can already see by the adding this is going to work out. Okay, so this is a yes. Pass. This is a right triangle, okay? So this is a right triangle. Okay, let's go to, let's try this one. Because this is a special case. This is an isosceles triangle where you have two equal sides. This one is different, that's why it only has a single hash mark. This is clearly, supposedly, the hypotenuse. This is side C. This is supposedly the 90-degree angle. But I think some of you can look at this and say, I think this might be greater than 90 degrees. Let's see if this works or not. I suspect it does not work. Okay, so how do we know it works? Well, look, and by the way, these sides are equal, so it literally, even more than usual, doesn't care which one it doesn't matter which one you call A or B. This definitely would be side C. If this was a right triangle at all, this would have to be side C. It's the longest side. 7 squared, 7 squared, 11 squared, 49. Oh yeah, it's not even close. Look at this. This is 121. This is only 98. It does not equal 121. Okay? Does not equal. So this is a no. Okay? So I'll let you do the rest. Okay, I'm just going to start this one. This is page 33. Obviously, it's number 6. Okay. So I love this type of problem. This is, I think this is cool. Most of you will think of it as a pain in the neck, but that's okay. So we've got to use the info off one triangle to figure out this area of X, which is shared, right? What do these two triangles have in common? They share their hypotenuses. So guess what? These two sides must be identical. It might be two different triangles. They are two different triangles, but they share the hypotenuse. For sure they do, because it tells you that this is a square. Okay? Or I guess I'll say this, if they, you can assume it's a square. So look, this is the only triangle here that gives you two pieces of information. You know that's enough. So X, this so-called X, is also the C squared value for both triangles. So this is the C squared value. Okay, so let's look at, I'm not going to do all of this, but I'll start with this one. A squared plus B squared is equal to C squared. Okay, so we've got, they've already done the squaring for you. So this, let's just call this A squared. The side length is A, but the area is A squared. This is the B squared on the B side. So what do we got here? 4 plus 24. I don't have to square these. It's already, look, this is the clue. It's telling you these are the areas. So you can just, the whole a squared is equal to 4. And the whole b squared is equal to 24. That's equal to c squared. 28 is equal to c squared. All right, I know that the square root of 28 then. So I'm going to write that in. 28. C squared is equal to 28. Therefore, remember my little symbol here? That means therefore. Therefore, the square root of 28 is equal to c. 28 square root. Let's call that 5.3. 5.3. Okay? Now, I don't really actually, when I look at this, I really don't even need to know this. I'm just going to put this in brackets. I think this is the most important information right here. Okay? So then what could you do? Let's call this triangle 2. So for right triangle 2, number 2, what do you know? You definitely have the c squared value. What are you going to call these? It doesn't matter. One is a squared, one is b squared. Let's call this a squared. So the y value is the area of the b squared. So I know a squared. I don't know b squared. Can you figure it out? Okay, I'm going to leave that there. All right, that was page 33, number 6. Okay, I'm actually quite glad that lesson 5 starts off like this, because you see two different pieces of info here. Okay, so step 1 is always identify side C. Okay, that's a right triangle. Okay, they gave us a little square, so this is 90 degrees. So this is side C. So that means this is side C. So we could find out what c squared is, right? We don't know yet. What are we going to call this? A or B? Doesn't matter. So let's call this side B. So this is b squared because look, they've clearly calculated the area. The side length is not 64. The area is 64. So that's b squared. This must be side A. So we have A, B, C. A is one of the shorter sides. B is one of the shortest sides. C is always the longest side. I don't even know what a squared is, but we could find out. Okay? So the cool part is a squared plus b squared is equal to c squared. Now watch. A squared, I don't know. B squared is given to me in terms of the area. It's already done the squaring. It's 64, so I'm going to immediately swap in 64. That's the whole b squared value. It's the area. Now for C, they only give us the side length. So here's what I have to do. I have to take this 10, and I do have to square it. I don't have to square the 64 because this is an area. This 10 is a side length, so absolutely I have to still square it. I love the fact that lesson 5 started off like this because you have to decide what type of info have I been given. Have I been given an area, an a squared or a b squared or a c squared, or have I been given a side length? And here, this triangle gives us both types of information. So a squared is equal to 64 plus 100. Now this is making sense because, of course, c squared should always be the largest number. Do a little algebra here. Okay. And so what are we left with? So in other words, we simplified. Okay, what's the simplified now that we subtracted 64 from both sides? This would be 36. Okay, so the area, okay, which is a squared, is equal to 36. And by the way, we now know c squared. That's 100. Okay, I guess we're dealing with inches. Inches squared. All right, now we can also find out the side length. Okay, take the square root of both sides. This, you have to follow the rule. Whatever you do to one side, you do to the other. So a is equal to the square root of 36. A is equal to 6. So the side length is 6. By the way, the side length here would be 8, square root of 64. This has already given us the side length. So guess what? The whole thing is done. Just to put on in the margins here. Did I figure out what the side length of A is? Yes. Did I figure out what the side length of B is? Yes. I didn't have to, but I did it anyways. This was given, right? Now a squared, did I figure out what that is? Yes. B squared was given, right? And then did I find out what c squared is? Yes. So given, so a side length was given. So this is a side. And these are areas. So 2 givens, I can still solve the whole thing. Okay, rounding numbers to the nearest whole. Round down. Round down. It just, remember. Okay, oh, there goes my lights. 137.8, you're going to round up. Okay, I'm going to pause here and fix my lights. Okay, so what is, like, you look at the 10th first. So that's definitely going to round up to 138. Look at the 10th first. That's going to round up to 20. To the nearest 10th, always be careful and read your directions. Nearest 10th. Okay, so this is 2, so 4. That's going to keep it at 6.2. 5.82, so that's going to be 5.8. So 0.1, the next digit is a 2, so that's 0.1. And 14 point, now look what happens here, okay? So this is the 10th, we're going to look here. The 8 will force this to round up, but we're already at 9. Like, there's no more room, so this now becomes what? 15.0. The 9 has to be rounded up to the 0, which forces the 14 to round up to a 15. Okay, that was all of page 35. Okay, this is page 36. I'll do one of these. Be sure to read this, right? It describes relationships. It's going to be the same thing over and over for like the next, like all the way to the end of the unit. Okay, find the length of the hypotenuse. All right, let's just use, it doesn't really matter. Okay, I'll do question C. A squared plus b squared is equal to c squared. It's really important to like still review, even though it says hypotenuse, what are you given? You are given the side length of A, and you're given the side length, oh, I'm off the camera. Okay, classic Smith. Okay, it's really important to review what you are given and what you're not given. So you're given an A and a B, and the C is the I don't know, the IDK. Once more, does it matter which one we call A or B? No. This is the most important identifier. You have to get side C right. It's always that opposite. Okay, so I don't know. I'm going to call that A. I'm going to call that B. So A is equal to 2, B is equal to 5. So we're going to put in 2 and then square it, put in 5 and then square it, and then whatever these numbers come out to, that'll be the value of c squared. So 4, 25, 29. Okay, and if it says find the length of the hypotenuse, so we can't stop here because it doesn't care about the area of the C, right? It doesn't care about this area. And so that's going to be what, 5.4 or something? Okay, it's close to 25 but above, so 29, 5.38. Oh, not bad, I said 5.4. So it is 5.4 if you round to the nearest tenth, again. 5.4. Okay, I'm going to move right along without break to page 37. Okay, so this is page 37. Really, it's, guys, it's all the same stuff. Okay, it's all the same stuff. All right. Let's do one of these where they're playing tricks with you with the naming or the labeling. Okay, so y is equal to 10, x is equal to 8, z is okay. So here's what you can do. You can reject the labeling if you want. And you can just say, look, this is really side C. It's opposite. Okay? Sorry, that looks like an E. This is side C. What is Y? Well, that's like an A, or that's a B. So you can either relabel the diagram, or you can relabel your formula. Okay? Okay, and I'll put it in brackets, or formula. Here's what I mean. So let's start with relabeling the diagram. So a squared plus b squared is equal to c squared. And we've got, I chose this to be my a, so let's make sure that it lines up. So a is equal to 10 squared, 8 squared, c squared, 164. So the square root of 164 is equal to c. That should be 12 point something, let's see, 12.8. What is it, 164? Hey, not bad, 12.8. Almost like it's not my first rodeo. Okay, 12.8 is equal to side C. Now, all I can say is or, and you might want to challenge yourself to do this, and I don't think it's that hard. You could write the formula in terms of the letters it actually gives you. So could the Pythagoras formula, like, do we have to forever and ever be locked into A, B, and C? Well, no, not really. Could we not just have said this is equal to x squared plus y squared is equal to z squared, right? Okay, so I'm not going to redo it all again, because the substitution and the number crunching is the exact same. All I'm saying is, yes, you can have permission to rename or relabel, use different letters for the Pythagoras theorem. What's the most important part here is that you have side z is the hypotenuse. It's all about what is the hypotenuse. This time I'm going to write out the whole word. The hypotenuse is z, or c if you chose to relabel it. That's the key. Find the hypotenuse. All right, I'm done with this page. Okay, this is the very next page, so it's page 38, and it's letter J. I thought I'd do this one just because it has decimals for sides. It's not a big deal because guess what? You're allowed to use a calculator. So this is our unknown. It's x, quote x, but we really know it's what? It's the hypotenuse. In other words, it's side C. Okay, so a squared plus b squared is equal to c squared. Which one is a? I saw this side first, I'm going to call it a. This is b. Doesn't matter. 8.1 squared plus 11.5 squared. Okay, it's not tough in the sense of, these are not perfect squares. I don't require you to memorize them. In other words, it's calculator time. Okay? 8.1 squared. Use all the decimals. Do not round here. So it's 65, 61. So if it says nearest tenth, that's for the final answer. Keep all the digits you possibly can. So 11.5, next one, 11.5 squared, 132.25. 132.25 is equal to c squared. Now I'm just going to add that to 65.61. 197.86. 197.86 is equal to c squared. The square root of 197.86 is equal to the side length. So I'm going to take the square root of that. 14.06. So I'm going to round that to one decimal place. 14.1 is equal to c. By the way, does this make sense? If I put in 14.1, you could just check your answers. This is 8.1, this is 11.5. Side C is supposed to be the longest. Is 14.1 bigger than either of 8.1 and 11.5? So yes, it does make sense. If you've gotten an answer, let's say you pushed the wrong buttons or did the wrong operation, you got an answer of 10.8, that this triangle would not make sense. Like, you cannot have that hypotenuse be shorter than this number. The hypotenuse must be greater than 11.5. It must be. By definition, the hypotenuse is the longest side. So there's always a quick way to check your answers. Okay, I'm done with this section. That was part of lesson 5 here. Okay, let me just talk briefly about lesson 6 for a minute, okay? You could think of this finding a so-called leg. In other words, this is one of the, shorter sides. Okay, so a couple of quick points, okay? And they have nothing to do with this. This is a review. I'm given both shorter sides, so just think of these notes as being separate. Okay, notes. If you're finding one of the shorter sides, okay, means there's always, in one of the steps, means there's always going to be, and I'm going to use gonna be subtraction as one of the steps. Okay? There's always going to be a subtraction. Okay? There's always going to be subtraction. That's basically all I have to say for now. I might add to this later, but there's always going to be a subtraction. Sorry, that's not spelled very nicely. Okay? So, let's see what that looks like. I'm going to do A for you. Okay, A. There's our little thing, our little square thing that shows that's at 90 degrees. So I'm given, okay, All of these you're going to be given. For this section of finding a leg, okay, it's just pure practice on one type, one style of question. So you're always going to be given, in this section for lesson 6, you're always going to be given a C